This is the first video of our Unit 4, which is on Newton's laws of motion. So we'll get to know Isaac Newton a little bit. We'll get to know his laws of motion, especially the first law called the law of inertia. So take some notes, because when you're done with this video, you should be able to explain Newton's first law of motion. You should be able to explain what is meant by that word inertia, which might be new to you or might not be. And finally, you should be able to describe what happens to objects in motion and objects in rest using Newton's first law. So let's meet Newton a little bit. Newton was actually known as kind of an unremarkable student. He kind of flew under the radar, and he was a little bit known a little bit as like a slacker. You probably know Isaac Newton because of his law of universal gravitation, which famously and legendarily he came up with while sitting under an apple tree, and an apple fell, and that was, by legend, inspiration for his law of gravity. But that's a little bit misleading, and I'll tell you why in a second. Another thing we know about Newton is that he was a stud. Look at this guy. He's a handsome fella, just like most scientists. Also, in addition to the law of universal gravitation, Newton is credited with kind of inventing calculus to some degree. And also he used prisms to show that white light is actually made up of a rainbow of colors called the visible spectrum. Now, the thing about Newton that's a little bit misleading is because with his law of universal gravitation, people think that he was sitting under an apple tree and an apple fell on his head, and that just kind of popped the idea right into his mind. But in actuality, Newton was known as a thinker. So he didn't kind of come up with these ideas out of sudden insight or inspiration, but instead he thought long and hard about things. So his mind was always working, even though he wasn't always making kind of products. And that's why people kind of regarded Newton as an unremarkable student. But the ideas that he had, he thought long and hard about them, and really came up with things that revolutionized physics, mathematics, and science. Now in physics, Newton is most known for his laws of motion. And they don't have very creative names. They're called Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. And that's kind of hard to remember. So instead, when we talk about them, we're going to talk about them: the law of inertia for the first law of motion, the law of mass and acceleration for his second law of motion, and his law of action and reaction for his third law of motion. This video is going to focus on Newton's first law of motion, and we'll do other videos on Newton's second law and Newton's third law later on. So, Newton's first law of motion, the law of inertia, can be stated like this: every object continues in a state of rest, or continues at a constant speed in a straight line unless acted on by an outside force. Now hopefully some of that sounds familiar from our discussion of force in Unit 3. Remember how we said that an object could be in equilibrium if the sum of forces acting on that object is 0 newtons? And we said that object was in equilibrium. And an object at equilibrium could be at rest in static equilibrium or moving in dynamic equilibrium. And an object in dynamic equilibrium has to be moving at a constant speed in a straight line. So you could reword this as saying every object stays in equilibrium unless there's an outside force acted on it. Now there's another, more common way of putting Newton's first law, so let's check that out. So Newton's first law can sometimes be summarized as objects at rest tend to stay at rest, and objects in motion tend to stay at motion. And the big key is unless there's an outside force. So an outside force will disrupt this equilibrium. And that's it, Newton's law of motion. So let's look at a couple of examples. So objects at rest tend to stay at rest. A classic example of this is the tablecloth trick, where you have a place setting set up on a table with a tablecloth on it, and you can pull the tablecloth out from under those objects and they stay put. They stay at rest, even though the tablecloth is being pulled out from underneath them. we're going to do a lab in this unit where you're going to actually try that. So the place setting is at rest, and they're going to tend to stay at rest. And that's because of Newton's first law of motion. Another example of objects at rest tend to stay at rest could be like with a wagon. So I've seen my kids do this, and I remember doing this as a kid. So you're sitting there in the wagon, and you're still, and your friend or your sister or something comes, and they pull the wagon really hard. You say, I want to go fast, I want to go fast. And so they pull the wagon really hard after you're sitting there at rest. And what's going to happen to this kid? Well, if she pulls hard and he's at rest, he's just going to go toppling out and crash his head on the ground. And that's because the wagon starts moving really fast, but the boy is going to stay at rest, and that's going to cause him to topple over. Now let's look at some examples of objects in motion tend to stay in motion. And one example of that is a car crash, or when you stop your car really suddenly and your body keeps going forward. So here's a guy on a motorcycle, and that motorcycle was going really fast with the guy on it. So what ended up happening was the motorcycle stopped really quickly by crashing into these tires, but the guy didn't stop. So the guy stayed in motion, and that's why he went flying off of the motorcycle. Another classic example is, hopefully you've played air hockey, where these little holes on the air hockey table blow air, and that creates kind of a frictionless cushion of air that the puck can glide over. So if you hit that puck is going to stay in motion unless an outside force acts on it. And that outside force could be crashing into the wall or crashing into one of these little hitter things or whatever they're called. So hopefully you get the idea. Now Newton's first law, it sounds more complicated than it is, but you see it all around you all the time. Another name for Newton's first law is the law of inertia. So to be able to really understand this, we have to know what inertia means. Now you just saw a bunch of examples, but we weren't really calling it inertia. So what is inertia? Inertia is the property of objects to resist changes in their state of motion. And it's just what we said. An object at rest tends to stay at rest. So it resists moving. If you're stopped, you say stopped. An object in motion tends to stay in motion. It resists stopping. So if you're moving, you keep moving. So if you have to write a definition for inertia, think about it as the property of objects to resist changes in their motion. And it goes hand in hand with Newton's first law. The last example that I want to talk about on this last slide is a really cool example of Newton's first law. So imagine that you're on an airplane, or you're in a car or standing on a bus or something like that, and you flip a coin. What's going to happen to the coin? Is the coin, when it goes up in the air and you let it land, is it going to land behind you? Is it going to land in front of you? Is it going to land at your feet? And this was something that really puzzled physicists a long time ago. And they really couldn't test it because they didn't have planes and fast-moving cars way back when. But we can test it today. After thinking about it, what did you come up with? What do you think? In front of you, behind you, or at your feet? Now the answer is, if you flip a coin, it's going to land at your feet. And the reason is, if you're moving in a bus and you're moving this way, the bus is moving that way, and since you're on the bus, you're also moving this way at the same speed, and since the coin is in your hand, it's also moving that way at the same speed. Now what happens when you flip the coin and it goes up? Its inertia, the resistance to change in motion, keeps the coin going this way. But by you flipping it up, it also added another dimension to the movement of the coin. But still, all during that time, the coin is going to be traveling to the left, and it should land right back in your hand. Kind of tricky? Don't believe me? Try it when you're driving home today. That's all for this video. When you're done with this, ask me for the video quiz. You can take the video quiz, then work on your problem set.